Hey everyone, and welcome. Today we're going to dive into the fundamentals of JavaScript. And we're not just going to talk about it, we're going to do it. Think of this as us coding together, watching our commands come to life right on the screen, one line at a time. Okay, so what's on the menu today? Simple. First up, we'll learn how to write our very first instructions. Then we'll figure out how to make those instructions reusable. And finally, we'll get into organizing more complex information. Let's do this.
All right, section 1, we're starting right at the very beginning. Before you can write a story, you've got to learn your ABCs. Well, in programming, that means telling the computer what to do and actually seeing it listen.
Okay, first things first, let's write our very first command. Imagine we're typing this right now. Console.log, then some parentheses, and inside quotes, we'll put our message. Hello, Tofas. Okay, we hit enter, and boom! Look at that. Right there in the console, it prints our exact message. We literally just made the computer talk. How cool is that?
That's awesome, but it's a one and done kind of thing. What if we need the computer to remember something for us? Well, for that, we've got something called a variable. And honestly, the best way to think about it is just like a labeled box. You can stick some information inside, slap a name on the box, and that way you can find it and use what's inside whenever you need to later on. Okay, let's actually make a couple of these boxes. First, we'll type let name equals Ali. And just like that, we've got a box called name that's holding the word Ali. Easy enough, right? Next up, let age equals 15. Another box, this one called age, holding the number 15. Now for the magic trick. Let's ask the console to show us what's inside both name and age. And check it out. Ali and 15. It remembered both, no problem. And of course, what are computers amazing at? Math, right? So let's give it a simple problem. We'll make a new variable, x, and we'll tell it to hold the answer to 5 plus 3. Now what happens when we ask the console for x? See, this is interesting. It doesn't just show us 5 plus 3. No, it does the work first and gives us the final answer, 8. So simple, but that's a really powerful concept. So up to this point, our code is pretty linear. It just runs one line after the other, top to bottom, no questions asked. But the real power of programming, the thing that makes it smart, is when we can get it to make decisions based on the information it has. And how do we do that? We use something called an if statement. Think of it like a bouncer at a club or a gatekeeper. Let's try it out. We'll create a variable called mark and set it to 70. Now we give the gatekeeper its rule. If this mark is 50 or higher, then you can let the code inside pass through and print passed. So the computer takes a look. Is 70 greater than or equal to 50? Yep, it is. So the gate swings open and bam, our pass message shows up on the screen. Okay, that's section 1 down. We've got the hang of single instructions. Now let's build on that. In this next part, we're going to see how to deal with repetition and how to package our code into handy reusable blocks. So imagine you needed to print the word hello 5 times. I mean, you could just write the same line of code 5 times, right? But that's so clunky and inefficient. There's got to be a better way to just tell the computer, hey, do this thing 5 times and then stop. And of course there is. It's called a for loop. This visual breaks it down perfectly. We basically tell the computer to create a counter. We'll call it I and start it at 0. You can see right there in step 1, it runs our code and prints count 0. Then here's the clever part. It automatically adds 1 to I. Now I is 1. Is 1 less than 5? Yes. Okay, run the code again. And it just keeps doing that. I becomes 2, then 3, then 4, each time printing the count. Finally, I becomes 5. Is 5 less than 5? Nope. And just like that, the loop knows its job is done and it stops. So variables are perfect for holding one piece of information. But what if you have a whole list of things, like a grocery list? You wouldn't want to make item 1, item 2, item 3. That would be a mess. This is exactly what arrays are for. It's like one big variable that can hold an entire ordered list of items. Let's make one right now. We'll create an array called fruits, and we'll put apple, banana, and orange inside. Now, here's a super important thing to remember in programming. We almost always start counting from 0. So apple isn't in position 1, it's in position 0. Banana's at 1, orange is at 2, and so on. So if we want to grab that first fruit, we ask for fruits at position 0. Let's run it and see. Yep, there it is, apple. Okay, so loops are great for repeating code right where you are. But what if you have a chunk of code that's so useful, you want to use it all over your program?
copying and pasting is a recipe for disaster. The smart way to do this is to package that code into what's called a function. You basically build a little code machine, give it a name, and then you can call that machine to do its job anytime, anywhere you need it.
All right, let's build one of those little machines. We'll call it greet. Its one specific task is to take a name that we give it and combine it with the word hello. So now that we've built our greet machine, let's put it to work. We'll call it and hand it the name Sarah. We run the code, and what does it do? Exactly what we built it to do. It gives us back hello, Sarah. Perfect.
Now, we can also get even more control over our loops while they're running. Take a look at the example on the left with the word continue. When our loop's counter hits the number 2, that continue keyword basically tells it, skip everything else for this round and just jump to the next number. And that's exactly why you see 0, 1, then it skips 2 and goes right to 3 and 4 in the output. Now look at break on the right. This one's way more dramatic. The second our counter gets to 4, break just yells, stop, we're done here. And the entire loop just ends right then and there.
All right, we've come a long way. We've gone from single commands to creating these awesome reusable blocks of code. So for our final section, it's time to really level up. Let's look at how we can organize different bits of related information into a single, clean, structured package.
You know, think about something in the real world, like a student. A student has a name, an age, maybe some grades. All those details belong to that one student. Now, we could have a bunch of separate variables, but that gets messy fast. A much better way is to group them all together in an object. The slide calls it a digital filing cabinet, and that's a perfect way to think about it. It's one container for all the related info about a single thing. So let's build one. We'll create a student object. Inside these curly braces, we'll add our properties. Name will be Omar, and age will be 16. See how neat that is? All the student's info is in one place. And now, if we want to get just one piece of that information, it's super easy. We just ask the student object for its name property, and what do we get? Omar. Everything's perfectly organized. Okay, objects are fantastic for describing one student. But what if your app needs to handle like hundreds of students? Are you going to type out that whole object structure every single time? No way. That would be a nightmare. And this is the exact problem that a class is designed to solve. A class isn't the student itself. Think of it as the blueprint or the cookie cutter, used to create as many identical students as you want. This is kind of the final piece of the puzzle. First, we define our blueprint using the class keyword. We'll call it person. We're designing it so that any person we make from this blueprint will have a name, and they'll also have a built-in ability to greet someone. Okay, blueprint's done. Now let's use it. We'll create a new person and we'll name her Mona. Now here's the magic. Because Mona was built from our person blueprint, she already knows how to greet people. We don't have to teach her. We just call p.greet, and she does her thing. Hello, Mona.
So let's just take a second and look at the awesome toolkit we've built today. We started with variables, which are just boxes to store our data. We learned about loops to repeat actions without writing the same code over and over. We packaged our code into functions to make it powerful and reusable. And finally, we used objects and classes to bring some serious organization to our complex information.
And that's really it. From a simple console.log all the way to designing your own blueprints with classes, you've just walked through the fundamental logic that makes the web work. This stuff powers almost every website and application you use every day. These are the building blocks. So the only real question left is, what are you going to build first?